All right, so we did some practice graphing. It's obviously tedious, it takes a long time, and it's important because the more you do it by hand, the better appreciation you have for the intricacies, the little parts that go along with graphing sine, cosine, and then eventually you're going to take that into tangent, cosecant, secant, and cotangent. It's a huge part of pre-calculus and calculus, so the better understanding you have for it now, the easier it is later. It's kind of like learning kindergarten math, which I know is crazy to say at Algebra 2, but it is, the foundational parts of pre-calc, calculus, and beyond. It's just another language, but it takes practice, like any language, to be fluent with it. Unfortunately, though, while we're in quarantine, which is when I'm making this video for any future reference, I'm not going to be there to make you hand graph anything. And since your assignments are online so that you can check your work easily, I kind of wanted to spend some time then at least trying to give you an appreciation for the parts of the sine and cosine curves. So what you're going to do, you're going to go back to 9-4 if you've already gone through it. I want you to turn to page 488 so you can pause and get there and get your notebook out, because here are the key parts to the sine and cosine curve. You'll find these as the core concept on page 487, but the monitoring progress doesn't start till 48. And then at the bottom of page 488 as well. Okay, so here are the notes that I took for you. We're going to use Desmos. I've always wanted to play around with Desmos, and I never really gave myself the opportunity because I use my graphing calculator. It's what I've been using since I was in Algebra 2, and I'm just comfortable with it. So we have obviously some things that happen to the sine curve here, right? The parent function would be y equals sine of x, and this is y equals a sine of bx. The book does not put parentheses around bx. You need to understand that whatever is next to the n in sine or the s in cosine and so on for the other functions is what you're doing that function to. And then y equals a of cosine bx. So not much is actually that different. The a out front stands for your amplitude. That was what we used to have as our vertical stretch, and it actually kind of still is the vertical stretch, which if you haven't played around yet, you will see. The b in front of the x, well, that is how many cycles or periods are going to fit between 0 and 2 pi. The book has this great equation. Period is 2 pi over the absolute value of b. So if it ever asks you for the period, you have to take the absolute value of b, which you're always going to find in front of the x after the cosine, in front of the x after the sine, and do 2 pi divided by the absolute value of that number. That'll tell you your period. But when you look at b, this is how you graph by hand, or if you're looking at a graph online, you look at b, and this is how many times the cosine curve or the sine curve will fit between 0 and 2 pi. Obviously, I'll go into this a little bit further. Okay, I'm going to pause here on the notes part. I want to just take a look at that. So this is page 488, numbers 1 through 4. I'm going to switch us to Desmos, and I'd like you to go to Desmos while we're doing this as best as you can. That is the wrong button. Oh, let me switch my screen. Hold on one second. That way you don't see. Here's my face. And now let's share Desmos and not my football stuff that I was looking at before getting to work. Okay, so let's just graph the parent function. y equals sine of x. Okay, so this should look familiar. Some key things and vocab, well, not really vocab, but stuff that I want you to say. We have peaks and valleys, which I mentioned in one of the previous videos. We have peaks, valleys, and then I call this sea level. It's going to come into play later on in the next video. So the sine curve always starts at sea level. It goes up a mountain to the top. It goes down back to sea level, down to the bottom of a valley, back to sea level. That is one cycle. In fact, go up here to the toolbar. Make sure down here you're in radians. Now let's do what I did in our first sine video. Let's graph from negative 2 pi, and you just have to type in pi in your keyboard to get pi to 2 pi. Now, over here on the steps, do you remember what I made our boxes, our units on the x-axis or the theta axis? It was pi over 6. So I want you to type that in to pi over 6. Y-axis, you can leave whatever it gave you coming in, right? We know that it goes up to 1 and goes down. So let's take a look. I'm scooting around. We graphed from negative 2 pi to 2 pi by hand, right? So let's just take a look at 0 to 2 pi right now. Now you see it says actually pi over 2. I'm going to zoom in a little bit. There we go. Now this looks a little bit more like what we did. It's off just a little bit. This is a computer, so it can be way more accurate. But the sine curve, the y-intercept is at 0. We go to the top of the mountain. We go back to sea level. We go down to the bottom of the valley at 3 pi over 2. Think about where your finger is on your unit circle when you do that. And then back to sea level at 2 pi. All right, so let's take a look at number 1 on page 488. And the question is, identify the amplitude and the period of the function, graph it, describe it as a transformation. Okay, so we're graphing it over here. Make sure you graph it correctly. Y equals sine 1/4 sine of x. Let me zoom out a little bit. Okay, so amplitude, that's in front of the sine function, so the amplitude's 1/4. The period is 2 pi, so that's what number is in front of the x between sine and x? It's 1. 2 pi divided by the absolute value of 1 is 2 pi. Now, what does that mean, though? So the period means that one cycle of sine, so sea level to mountain, to sea level to valley, back to sea level, fits between 0 and 2 pi. That is one cycle, that's one period, okay? Sea level, mountain, sea level, valley, sea level, one cycle of pi. So the period is 2 pi because 1, right, the number in front of the x, the coefficient of x, 1 cycle fits between 0 and 2 pi. And we graphed it, and doesn't it look like the amplitude shrunk to 1/4, right? So 0, we can even click right here. Pi over 2, you can see pi over 2, comma, 1/4. Pi 0, 3 pi over 2, negative 1/4. So the amplitude, the vertical stretch, shrunk to 1/4, okay? That describes number 1. So now let's take a look at the cosine function for number 2. I'm going to go back to my parent function. I'm going to type in cosine of x. Let's just take a look at that. Now, cosine is different. You need to identify that one cycle or one period of cosine starts at the top of the mountain, goes down to sea level, down to the bottom of the valley, back to sea level, and ends at a mountaintop. So cosine is mountain to mountain. Mountain, sea level, valley, mountain, sea level, mountain, okay? So how does number 2, cosine, I'm gonna use parentheses because you know I'd rather be safe than sorry, cosine of 2x, change that? The amplitude is 1 because there is no number in front of cosine. Now this number 2 tells me that there should be 2 periods between 0 and 2 pi. 2 periods between 0 and 2 pi. So let's take a look. Does that work out in blue? Mountain, valley, mountain, mountain, valley, mountain. Yep, I ended up at 2 pi. And what once was mountain down to valley to mountain to get me from 0 to 2 pi, I now have mountain, valley, mountain, valley, mountain. So 2 cycles. And in fact, what is the period? It is 2 pi divided by 2. So what's 2 pi divided by 2? It's pi. And is that true? Mountain, valley, mountain, or mountain, sea level, valley, sea level, mountain. That would be one cycle. The one cycle ended at pi. Pi is my period. All right. So that's how that changes. I know it's a completely new lexicon, but the more you practice, the more you get used to it. So I want you to try saying these words as you do the problems on big ideas, okay? But I'm going to do numbers 3 and 4 with you, and they're going to kind of get weird, so using the right vocabulary will help. So back to, for number 3, the parent function is sine of x. Ooh, and it looks like they're trying to trick me here. And we haven't had too much practice, but this is number 3, 2 sine pi of x. So remember, my parent function's in red. Now what happened? Okay, it's kind of weird, but pi is a number. So first of all, the amplitude is 2 because it's in front of the sine. Sorry if you hear my dog drinking right now next to my computer. The amplitude is 2, and now the period is going to be 2 pi divided by this number, the coefficient of x. Well, what is the coefficient of x? It's pi. So 2 pi divided by pi is 2. So that means that between 0 and 2 pi, there should be, this is going to sound really weird, between 0 and 2 pi, there should be pi number of cycles. Okay, like 3.14-ish number of cycles, so 3 and a change, between 0 and 2 pi. And where does one cycle, one period end? It should end at 2. Let's see if that works out. So sine function, remember, we're looking at red right now. Sine function starts at sea level, goes to the top of the mountain, down to the bottom of the valley, ends at sea level. So you have one mountain, one whole valley, and that's one cycle. All right, so one mountain, one valley, one mountain, one valley, 2 cycles, one mountain, one valley, 3 cycles, and then some change, maybe 0.1415, yada, 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 of a cycle right there. So between 0 and 2 pi, we have 3.14, we have pi number of cycles. And where is this cycle ending? Look, if you put your cursor right there, it tells you 2, 0. What is one period of this sine function? It's 2 pi divided by pi out here, or 2, and that's where a mountain and a valley end at 2, 0. All right, let's see if you can get a head start for number 4 with me as I type it in. We're looking at the cosine function again, which means we're starting at the mountaintop, going all the way down in the valley and ending on the next mountaintop. What's my amplitude? 1/3. Okay, now some of you are still iffy with your fractions. You're so afraid of fractions, one of the F words, but you're not going to be. What's 2 pi divided by 1/2? It is 4 pi. 2 pi divided by 1/2 is 4 pi. So the amplitude is 1/3. Sorry, the amplitude is 1/3. The period is 4 pi. Or, in other words, look at this number, because this is where the fractions, okay? Half of the cosine period, one cosine cycle, should fit between 0 and 2 pi. So one whole cosine cycle, cosine period, is mountaintop to the valley to the top of the next mountain. That's one cycle, one period. Half of that should fit between 0 and 2 pi. So let's look at blue. We start at a smaller mountain, 1/3 of the height, top of the mountain, all the way down to the bottom of the valley. That's half of a cosine, and that's where it is at 2 pi. So how long does it take in blue to finish out one cycle? So mountain to valley to mountain, mountain to the bottom of the valley, sea level to the top of the mountain. Well, that's 2 pi divided by 1/2, or 4 pi. So one period is 4 pi. All right, that is amplitude and period, and also kind of how I want you to think about it. Practice with the assignment online that I assigned. I'm going to do another video that adds in phase shift and vertical translation or midline, okay?